Okay, so the A part of the question, you're asked just to get the ddx of 2x plus 2 sine x. You don't need to worry too much about the notation, lads, okay? If you just have 2x going to 2 and then sine 2x going to 2 cos 2x, you'll be fine. Right? On to the B part. B part is fairly straightforward. You're just asked to differentiate it. 5x squared goes to 10x. You need to be careful. The 5y squared, well, that's implicit differentiation. So you treat it as normal, but you put in dy dx. So it goes to 10y dy dx. The 16 at the end will go to 0. And the 6xy, again, you just need to be a little bit careful about that. You're going to use the product rule. U is 6x, y is v, so dy dx is equal to dv dx and du dx is equal to 6. Use your product rule, and then you take that and you put it back in, and you can see it's gone back in just here. Okay, multiply it all out. Everything with a dy dx is staying on the left hand side, so I'm at this point here in the question now. Everything with a dy dx stays on the left hand side, everything else over to the right. You're going to factorize out the dy dx, that's what's happening here. And you're going to divide both sides by 10y plus 6x so that you get dy dx on its own. Okay? So the next part of the question then says you've got 2 points, 1, 1 and 2, minus 2, and they're points on this curve, whatever it looks like. Show that the tangents at these points are perpendicular. So if you want, tangents are obviously lines, but once the question mentions perpendicular, all you really need is the slopes. So in other words, what the question is really saying is, show that the slopes at these 2 points are perpendicular. So you're going to take the first point, which is 1, 1. Sorry, a better way to write it would be dy dx evaluated at 1, 1. So that's going to be minus 10 times 1 minus 6 times 1. We'll work that out in a second. I'll read it. Minus 1. And then dy dx evaluated at the next point, which is 2 minus 2. So minus 10 times 2, you get the picture. Minus 6 times minus 2. I'm putting that in right. It should be a minus 10 times y, which is minus 2. And that will be plus 1. And that's to make sure that you get the marks though. In order to show that two things are perpendicular, two slopes are perpendicular, you have to multiply them to show that they equal to minus 1. So we take that off there. So multiply the slopes, show that they equal minus 1. You can just see there, therefore the tangents are perpendicular, and that'll do you for the question. Okay. Alright, so the part C. The part C is y is equal to sine inverse. That's an awkward one. And you're also asked, so first of all obviously get the derivative, but then you're asked to express it in a particular way. What I'd say to you is don't even worry about how you've to express it. Your first job has to be to differentiate it correctly. Having a look at that, what you're going to do, the way we've looked at doing it is, you put this all over 1 and you act as if this is u over your a value, u over a. So you've an identity in your log tables, you're going to use it. Where the identity though will be in terms of x, we're obviously going to put in u, but because we're using u instead of x, we have to make sure we multiply by the derivative. So at some point, off to the side, we're going to have to use the quotient rule on the what's inside the brackets. Okay, so what have we got here? Dy dx is going to equal to 1 all over the square root of our a squared, so that's going to be 1 squared, minus our u squared, times du dx. Now that line doesn't necessarily have to go in. Okay, I'm just putting it in there so that you understand what's going on. That will go to 1 all over the square root, well 1 squared is 1, minus u squared. And don't forget that still has to be squared itself, times the ddx, the derivative of x over the square root of 1 plus x squared. Okay, don't be too put off by it. Deal with. Let's just deal with what's the first bit, so the square root there. Tidying it up a little bit. 1 all over. I would say that it's going to be the square root of 1 minus, that's going to be an x squared, all over. Our rules of thirds say that if something is squared or to the power of a number, it can be the top squared and the bottom squared. So the square and the square root here are going to cancel, so I'll be left with 1 plus x squared underneath the line. I'd put that over 1 and I'd simplify it. So it's still all inside the square root, only it's going to all go over 1 plus x squared. You'll end up with that. And I'll leave it there. Well, I'll leave it. Well, no, I won't. On to the next page. I'll just finish it off and then I can come back. So what you'll be left with is your dy dx will be equal to 1 all over the square root 1 plus x squared. I will keep going with it. The square root there is easy to work with. You're going to be left with 1 all over the square root of 1 over the, I'll just put it in for you, the square root of 1 over the root of 1 plus x squared. I keep going. That's essentially division of fractions, so you don't need to put that in. You can say that it's going to be the root, and we'll just leave the 1 in there so we know what's above the line and what's below the line. Okay, now we have to go back and do the derivative part. Okay. So what I'm looking to do, I'll just put this in red because it's fancy. That's your u and your v. Now look, you could do this, you should be able to do something like this in your head. But if it comes to the leaving cert, you just make sure that you take your time and you do it correctly. It's not a straightforward quotient rule, it's chain within quotient because of that square root underneath the line. Okay? So du dx, that'll equal to 1, and dv dx, well, that's going to equal to a half times 1 plus x squared, sorry I know this is quite small now, 1 plus x squared to the minus 1 half multiplied by 2x. And just to tidy that up before we go any further, the 2's will cancel for me. I'd be left with x over, it's all to the power of minus a half, so that minus will bring it below the line, and then I'm going to change that half to a square root. Now that's not, you haven't worked out the derivative yet, you've just manipulated things to get prepared. So the derivative, the ddx, or du dx as it is actually called, quotient rule, so it's v du dx, so v, so it's going to be the square root times, so v du dx, where was du dx, times 1, minus u dv dx, and don't forget that's all over v squared. They will cancel off for me, so I'm just going to bring it over. I'll bring it all over so that you can see it, and then we'll work with it. You're going to have, so that's being multiplied by the square root of 1 plus x squared minus x squared all over the root and that's where we're at with it. Again, don't be tempted just to start cancelling things off. Put this over 1. We're going to simplify the derivative, and hopefully it'll all come together for us and it'll work out nicely. So it's still all over 1 plus x squared. Let's leave that alone for the moment. The LCM for the numerator is going to be the root of 1 plus x squared. So 1 into that is itself, so you're going to have the root of 1 plus x squared, all squared because it's been multiplied by itself, minus x squared. And we'll keep going with that. The square and the square root will cancel off for me. Above the line, I'll be left, hopefully, look, I'm just going to whip those off fairly quickly. You'll be left with 1 above the line. So 1 all over the square root of 1 plus x squared all over 1 plus x squared. Of course, if we look at that like that, that's division of fractions, invert and multiply. And I think what's key to just moving this forward, just that little bit towards the end, is that that's all to the power of 1. And that this portion here is all to the power of a half. So they have the same base number in effect. So I can actually add them. And I can say that all of this goes to 1 all over 1 plus x squared, all to the power, well, it's 1 plus a half, so it's just 3 over 2. I'll use green to pull it together. That's fancy. So this is going to come down, and this is going to come down, and they're going to combine, and this is your dy dx. So you'll have the square root of 1 plus x squared over 1 multiplied by 1 all over 1 plus x squared to the power of 3 over 2. Again, similar sort of a thing. The square root of 1 plus x squared, well, that's to the power of a half. Okay. So you can bring it down, and then you can do some subtraction or addition or whatever is required, or you can bring it up and you can bring it back down. So I'm going to bring it down just because. So that'll be minus a half times 1 over 1 plus x squared to the power of 3 over 2. I'm going to have to go on to a new page, sorry, a little bit tight there. So just to finish it off, 1 over, just to remind you what it was, again, effectively they've the same base numbers, so you say to yourself, well, I'm adding 3 over 2. 3 over 2 minus a half is a half. Okay, so where are we at with that? Or have I made a mistake? Looks like I have I? It's power of 1. Okay, sorry. Yeah, to the power of 1, and then that it will work out. Lovely. It wants it in the form a plus x to the b, so it's 1 plus x squared, and you're done. Okay, and a and b are an element of n, which they are. Okay, lovely.